You know, we hear so much about green hydrogen these days, often pitched as the silver bullet for, well, pretty much everything in heavy industry. But today, we're going to pull back the curtain and look past the headlines, right into the heart of the blast furnace. We're talking about green steel and why making it is so much more complicated than it sounds.
Okay, let's start with just one number. 8%. That's it. Let that sink in for a second. It's a huge number, and it represents one of the single biggest hurdles we face in tackling climate change. Any idea what it is?
Yup. 8% of all the carbon dioxide we pump into the atmosphere every single year.
That's the price of making steel. I mean, think about it. It is the literal backbone of our civilization, from skyscrapers to paper clips, but the way we've always made it is incredibly dirty, and that has to change. The real question is, how?
And this is where hydrogen steps into the spotlight. You've heard the hype, right? On the surface, it looks like the perfect, almost elegant answer to clean up one of our dirtiest industries.
And just to give you a sense of the scale here, we are talking about nearly 2 billion tons of steel made every year. So yeah, cleaning this up isn't just a small tweak. It's a monumental global industrial revolution.
All right, let's get a little nerdy for a second, because the chemistry on paper is beautiful. I mean, look at this. The old way, you use carbon monoxide from coal to rip oxygen off of iron ore. You get iron, sure, but you also get a ton of CO2. The new way, you use hydrogen, and the only thing that comes out is water vapor, H2O. It seems like a no-brainer, a perfect one-for-one swap.
And look, this isn't just some fantasy. The experts, the people deep in the industry, they all agree that this process, combining hydrogen-based direct reduced iron with an electric arc furnace, is the absolute frontrunner. It's the horse everyone is betting on for truly clean steel.
But, and you knew there was a but coming, right? This is where our nice, simple story gets complicated. Because it's one thing to have a neat chemical equation, and it's a whole other thing to rework an entire global industry. This is where the hype smacks right into the hard wall of metallurgy.
So you have to be asking, if it's so perfect, what's the holdup? Why isn't every steel mill doing this right now? And that is the million-dollar question. The catch, believe it or not, isn't in the chemistry. It's in the physics.
And here it is, the big twist. It all comes down to one crucial technical term, endothermic. See, the old carbon reaction was exothermic. It actually produced its own heat, kind of like a self-sustaining bonfire. But the hydrogen reaction is the total opposite. It gets cold. It sucks heat out of the system like a sponge. You have to constantly force-feed it enormous amounts of energy just to keep it from grinding to a halt. And that one little fact changes absolutely everything.
And you can see the ripple effects right here in the data. The temperatures are completely different. The amount of time the ore has to cook is longer. Now, you do get this incredibly pure iron at the end, which is great, but the entire process, the furnace itself, has to be completely redesigned from the ground up to manage this new reality. Honestly, this is the best way to think about it. It's not like just swapping a gas line for a hydrogen pipe. It's like ripping out your gas stove and installing a microwave. Yeah, they both cook food, but how they do it? The equipment, the physics, the results, they are fundamentally completely different worlds. So this one change creates this whole cascade of new, tricky engineering puzzles. For starters, the iron you make is actually too pure. It doesn't have any carbon, which you absolutely need for steel's strength, so you have to add it back in later, very carefully. Then the waste material, the slag. Its chemistry is all different, messing with the process. And hydrogen itself, it's a diva. It has to be incredibly pure, and worse, it can actually make the steel pipes and tanks brittle, which is not great. Okay, so we've got all these problems inside the plant, but the headaches don't stop at the factory gate. No, they ripple way, way out, affecting our entire energy and economic systems. Let's talk about power. Just look at this number, 2,000 gigawatt hours. It's hard to even wrap your head around how much electricity that actually is. That's the amount of juice you need for 1 year to power just one medium-sized green steel plant. We're not just building a new factory here. We are plugging a new city's worth of demand directly into the grid. And all of that power has to be renewable, or the whole green thing is pointless. And of course, all that energy isn't free. The bottom line is right now, green hydrogen costs way more than the fossil fuels it's supposed to replace. Overcoming that price gap, that green premium, is probably the single biggest economic hurdle of all.
All right, let's switch gears from dollars to people. Here's another number for you, 70%.
That is the share of the existing steel workforce
that is going to need some serious retraining. We're talking hundreds of hours per employee, learning totally new skills, from how to handle hydrogen safely to running complex new digital systems. It's a massive human challenge.
So with all these hurdles, the physics, the cost, the training, it's really important to remember something. Hydrogen might be the favorite, but this is not a one-horse race. There are other ideas competing to build the future.
And this brilliantly illustrates the main alternative. On the left, that's our hydrogen process, using a gas as a chemical middleman. But on the right is something called direct electrolysis. This approach is kind of wild. It wants to skip the middleman and just use raw electrons from the grid to rip the oxygen away from the iron. It's a more direct path, but man, it comes with its own set of extreme material science challenges.
So when you step back and look at the whole landscape, yeah, hydrogen DRI is clearly leading the pack. But don't forget, just recycling scrap steel is already a huge low-carbon win. And some folks are trying to bolt carbon capture systems onto old furnaces as a bridge technology. Electrolysis is the dark horse. The point is, the race is still on.
At the end of the day, it really comes down to this. No single company, no single government can crack this code alone. It's going to take a massive coordinated effort from engineers, scientists, policymakers, and investors, all pulling in the same direction to make any of this a reality.
And that really brings us to the core takeaway. The challenge was never just about finding a clean chemical equation on a whiteboard. It's about engineering a robust, reliable industrial process that can produce the backbone of our world, day in and day out, without wrecking our climate. The race for green steel isn't just a race for new fuel. It's a race to master an entirely new kind of industrial physics. Thanks for tuning in.